I think so. Sorry, Tom. Thank you very much. Yeah, I think so. Can you guys see me now?
Yep, go full screen.
Fantastic. All right. Excellent. Well, Tom, thank you very much for the invitation. What I'm going to be showing today is a pyrolysis unit that we have been developing all this year. And I want to show you why we think these modular systems are a system to implement in the future. No, implement here in the US or around the world. Okay. This is, starting from the end. Let me see. This is at the end of this conference. I want you to take. This is the message I want you to take. We need more of this kind of system, modular, so we can move it around. We can produce biochar in different places and save cost, operational cost, in transportation and logistics, and capital cost in the infrastructure. But these are the systems that we build. You see a truck coming in. This is a walk-in floor trailer, and we automate those. Goes to a bin, and then it enters into our reactor. And this is again a screenshot of how our models work generally, and depends in each of the feedstock that we're using. But basically, it comes in, it grinds, it dries, and then it pyrolyzes in the pyrolyzer. Then we have different ways of quenching. This is one of them. We quench them, and then it go into bags, for example. These are modular systems, and obviously, depending on the feedstock that you're using, what are the equipments that you will need. But this is pretty much the basic model, and obviously there are tons of things that we can add. We add heat exchangers, or we add milling system for the char, or sprayers for adding microbes or nutrients or such to the biochar. But this is a simple system. Okay, the dryer uses their own heat from the reactor, so we make it a lot more inexpensive and simpler to use, less operational cost. What else? And obviously the pyrolysis uses its own gases that we combust some of those to provide the heat. But that's how we do it. And what I'm going to be, very simple, my presentation, I'm going to be talking about these four words: ARTi, modular, pyrolysis, and systems. Why, through all our years of ARTi and my years in the university, why we came out to this concept. Well, ARTi, we're a group of students from Iowa State. We work in a thermochemical conversion lab for Dr. Robert Brown. We do all sorts of pyrolysis and other thermochemical conversion. But again, from that lab we came out to develop pyrolysis systems because we were doing very incredible research. But now we felt the need of taking it outside to the industrial world. This is our first project, was in Nicaragua, but we learned so much. And for me, it's like a perfect analogy of the biochar industry today. So it's how to make biochar inexpensively, simply, with any waste material, all sorts of things. And we made biochar with this semi-continuous kiln, and we produce quite a bit of biochar that for us, we use it for our research, measuring carbon dioxide emissions in agricultural soils. So we did that, and it was a beautiful experience. All right, from ARTi, we started developing years ago modular systems and see how we can make them better and more self-sustaining and just more efficient in general. And I'm going to show you why I think the modularity is something that we need to think more and more into industry. Not for every case, right? But we see the modularity a necessity in many of these operations in order to make them economically viable. And more we see that biochar is a great product, but we don't see why it's not being implemented in the field. And for us, the major drawback of the biochar is the price. And why is that? Because the technology is not simple to make. We're using a lot of energy, a lot of labor, a lot of automation, a lot of capital cost. And at the end of the day, we need to sell a biochar that is $200 a yard or $300 a yard. And careful, it's $200 a yard, but in a tonnage base, you're talking about $800 per ton or something like that. So you are in the range of the expensive carbons. So those are the things that we need to be very careful. The economics and the simplicity. So when you're comparing, this modular system to other infrastructure, then you need hundreds of thousands of dollars. Or where you're moving biomass 100 miles. moving biomass 100 miles, and in some cases like this one, which is 50% moisture, imagine how expensive that gets. Or when you're saying, yep, we need to paralyze this biomass, but this biomass is wet, it's large, it's kind of difficult to move around, or the handling systems that we need. Well, all those things add to the front end, and then makes things a lot more complicated, a lot more expensive, right? And again, I'm not talking about the biochar quality and the systems itself, but the complexity that the biochar industry has to overcome in order to make successful businesses. So this is a picture of the Bioeconomy Institute. Excellent, beautiful place to do research. We did great research here. And this is just an example. No? And again, these numbers, these are techno-economic analysis that we do. Every client is different because they use different inputs. And here I just put in some very big numbers for you to take home. Is if you're using facilities that they're a couple of $100,000s, okay, you need to produce a lot of biochar in order to dilute that. And to produce a lot of biochar, that means a lot of transportation, a lot of biomass, and a lot of things. For this model, in this model only, if you're saying we're going to be using this kind of infrastructure for this client, would translate in $150 per ton of the biochar because of the complexity of a facility and the expenses involved. Okay, when you're talking about transportation, look at this. If you transport 100 miles, you say, well, yeah, it's a couple of dollars per mile, $3-4 a mile. Careful, it has to be a round trip. Careful, you might be transporting 50% of moisture, and you need a lot of equipment to load it and to unload it. At the end of the day, in this project, every ton would cost between $50 and $200 a ton of the $50 or $200 per ton of biochar. It's a lot of money. We're talking about $800 a ton of biochar, and you're putting only in the feedstock transportation or in the capital cost associated with the infrastructure, a lot of money, a lot more money. So your margins are very small. We need to see margins of 30 or 50% in order to make businesses more economical. And careful, I talk to my clients, say, well, we're thinking, for example, on a dryer. If we buy this dryer, we make it run with $50 per ton of biomass. Great. Keep in mind that when you paralyze it, you're pretty much paralyzing 3 or 4 tons and you're producing 1. So that $50 a ton that you're saying, at the end of the day, could be $150 or $200 in cost in the final biochar. So it is very significant. That's why we need to think, in a broader space, in a broader picture. There's so many items that we need to understand for the systems. Pyrolysis. Why pyrolysis? There's so many ways to make biochar. And careful people saying good or bad biochars. I would just say biochars that are for different applications. But as you guys know, you can do torrefaction, carbonization, slow, fast pyrolysis, ours is in between, is a medium, gasification, hydrothermal liquefaction. There are lots of processes. And these are the biochars that you can be processing. They're completely different. So you need to understand your system and what you want to do. And then we start talking about, some of the things on the biochar that we need to be very careful, like the previous talkers were saying, is, well, what we promise. Careful when you promise all that and you're producing this, they're very different. So we have to know what we're doing and what they're good, those materials for. Other things that I talk to my colleagues all the time is careful with, calling charcoal or carbonization. This is the legacy of carbonization, which we cannot. I mean, it's great in some parts of the world as a first step to move it forward to other systems more advanced. But the smokes and all the process of emissions or consistency of the product or all the issues that we have with operation, well, those are things that we need to overcome. So don't call it charcoal, because charcoal has a bad reputation. And we need to move ahead with system more advanced, like what we are proposing, something more automated, that with one person or less than that, you can be operating and producing tons. That's the idea. And careful with the quality or the properties of your biochar. And like Tom was saying, is we need to focus on design biochars. We need to make a carbon that we know what it is and we know what it's good for. Oh, I just realized I forgot my camera. All right. Well, I don't know if it works, but anyway, so what is our point? Is we help the clients from the machines to define the product to make a good biochar product for their systems. Okay, and there's a lot of technical parameters. It's not just making charcoal. You just need biochar. And what I was referring in the past, what is good and bad biochar? Well, that's another topic of discussions. But this biochar is good for this application, and you always need to consider everything. Like in agronomy, you need to consider the soil, the plants, the environment, and what you want to do with that. So, I mean, it can get a lot more complicated. So we talk a little bit about ARTi, why modular system we're proposing those. Why the pyrolysis? Because we need carbons that we know what we're producing. It's not just burning something and making charcoal and then calling that biochar and using this broadly. It's not a bad, it could not, it could be a good biochar, but you need to know what you're doing and how you're using it. That's the whole point. And now I'm going to be talking about systems. A little bit I've been talking in the past is why we need to approach it as systems. We don't sell pyrolyzers, we sell systems to make biochar products. Excellent. So again, like you see in any facility, the amount of equipment that you need is very significant. And then you start buying all those components, and only in the integration and automation, you spend so much money. And what we're trying to do is make it simple for the client. You tell me what you want, we put it and we manufacture it and we assemble for this situation and we make it work for you. So we build anything. We build all sorts of augers, conveyors, milling systems. Some of these are patented already, most of them are. We make reactors. This is the reactor. This is a pyrolysis reactor that the material comes. They're simple augers, know that we can troubleshoot, we can fix. The client can go and get the materials mostly local, most of them. So they're simple. They're simple to automate, simple to operate, simple to maintain. Those are the keys. We make afterburners for those, and again, for more specific situations. Not all of them will require it. And then we do cooling systems, and we do bagging systems and mills. We do mills. Again, we're making biochar products. So when you're talking about, well, we're going to mix this in animal feed, or we're going to mix this in a compost, or in a filler for plastics, or whatever filtration, we do other equipment just to provide turnkey solutions to the clients. These are examples of, drying and equipment for labs and entrepreneur equipment that we can develop biochar products. Okay. So again, what we're trying to do, modular systems. Modular, simple, automated, that they're self-sustaining energy. Actually, we export a lot of energy for other processes if we need. There's plenty of energy in the biomass. Careful when using very wet materials, but there's plenty of energy. And they're simple. This is a container. We move it with a truck. In 8 hours, we take all these components out. We put it inside. We move them around. And then in 8 hours, we bring it down and we assemble it back again. And this is a simple automated system. We automate the walking floor and we automate every component inside. And these are some examples of machines in our development of the company and the concept of how things have been evolving. But basically, the most successful components from our system, I think, has been the modularity and the simplicity. So you can make biochar, and you can make it not so expensive, not so complicated, with many feedstocks, many feedstocks. So again, here is just a quick snapshot. All right. So this is some of the directors of ARTi. And we make biochar, we make assemble biochar, manufacture biochar systems, and we do a lot of consultation in engineering, because every biochar system is a challenge. All right. And for you guys, we are selling biochar and we're having all sorts of promotions. And now that it's Christmas, consider buying some biochar for the naughty kids. That was a kind of a quick advertising from our marketing team. Well, thank you very much, Tom. I might have a little bit more time, but if you guys want to have some questions or else I can address those.
Okay, thank you very much, Bernie. We'll have another presentation, and then we'll have a general discussion session with questions. And one of the things that Bernie's presentation illustrates, I think, is the something that all of the technology providers face, and that is the need to develop products as well as technologies. So in many cases, you need to be teaching the people who want to use your system what products they could make and how they make products with particular characteristics. So if Bernie, you can stop sharing your screen. I think next we have Christopher Carsons from Carboculture. Okay, I had a question for Bernie. Bernie, you've got a couple of units in operation. I think you've got one on poultry litter. You probably tested, like everybody else, everything under the sun.
Yes.
Where's the best fit for your modular system, and what about capacity? You advertise 10 to 40 tons a day. Where do you see these things landing? Most people, in terms of both the capacity and the types of products they might make.
Okay. So in terms of capacity, every pyrolysis train, which we can put many in a shipping container, up to 5 of them, would process around 8 to 10 tons of biomass per day. Okay. So you would be producing roughly 2 tons of biochar per day. Again, the biomass feedstocks they vary quite a bit. So, but general numbers would be those to use. So how we scale them up, we put more. That's what we found more convenient for an operational approach. Now you don't have a huge machine to turn on and waste 6 hours. It's just each individual train turns on and actually helps heating the other one. So makes things a lot easier in the operation. So in terms of capacity, if you want to think of 10 tons a day of biomass production, one train. So 3,000 tons a year. That's what I would encourage these kind of applications for. From there, lower or more, but that would be one train. And then we can put in a shipping container, careful, because then there's no space for dryers or grinders, but we can put up to 5 of them in one shipping container. Okay, we have been, the concept is the same. We built dual systems, but moving to more parallel trains, those one we can do it is just the same approach, right? So that answer your question, Tom, or should I explain a little bit more?
A couple of other questions. One is, what feedstocks have you been using? There's someone interested in using the waste heat. So what are the emissions? Are there emissions issues from using the waste heat?
All right, let's start with the easy one, is the feedstock. We have pyrolyzed everything from biosolids to manures to obviously wood products, agricultural products. We have pyrolyzed bones. We have pyrolyzed byproducts from the industry. I would always suggest the client to start with the easy. What is the easiest? Biomass. Typical woody biomass would be the easiest one, and lower moisture and particles that are already done. Already, you don't have to grind it or separate them or anything. So from then you can pyrolyze a lot of things. Again, if there's energy and carbon, we can pyrolyze it. All right. With that being said, now we're going through the emissions. Can you pyrolyze plastics? Absolutely, you can pyrolyze plastics. Careful, because now the pyrolysis won't be the problem. Would be all the emissions that again, it's not the problem. Yes, there is a challenge, but there are lots of equipments nowadays that you can buy and you can integrate into all this equipment. So when you're talking about afterburners, we make one, but you can go to the market and buy one, or all sorts of wet scrubbers and filters. So can you pyrolyze it? I would say absolutely you can pyrolyze it. Careful, because some of those biosolids, for example, we can have a lot of issues that we need to correct on the stacks afterwards, and that is expensive. So regarding the emissions, what was the question with emissions again, Tom?
Well, I think you answered it. Basically, the emissions can be taken care of basically with the appropriate afterburners. The other issue with emissions is that you're a small scale, and so that's a benefit from an emissions point of view. You're kind of under the threshold of emissions, probably in most applications. There was a question about what's your business model? Are you selling units that people use, or are you selling units, leasing units and selling products? Are you selling biochar products? Are you doing all of the above? I know you are.
So Tom, yes, we do everything. So So we do engineering consultation. Some years, engineering consultation is our major activity. Some others is manufacturing equipment and selling and installing them and commissioning. Some others is just selling biochar products. We do sell online. Go to our website, purchase something, help us out. We do sell. It's not a lot, but there's always a couple of super sacks here, there, a couple of tons, or a couple of small bags and things. We do R&D a lot because it's what we talked before, in the sense of it's not just selling biochar, you need to sell biochar products. And having that R&D capacity from Iowa State, we do all sorts of analysis there, give us know-how that we can translate that into our clients afterwards. So all the above are very important. But basically what we will do more would be machines and engineering and consultation. Some clients, we work with plastic industry and developing carbons for them and doing all sorts of chemical characterizations and changes so they can use it properly in their fillers, or match this tensile strength or this flammability or stuff like that. So we do pretty much everything, Tom.
Good. Well, I got to switch here to Chris. Question for Chris: does your